Hey guys, it's Ms. Tommaso. We're going to do our Chapter 7 study guide over similarity in triangles. And so we're going to get ourselves started. So just remember that similarity means two triangles that are the same shape but different sizes. So some kind of dilation has occurred. Either it has gotten larger or it has gotten smaller by some scale factor. So questions number 1 through 3 ask, are the polygons similar? And if they are, to write a similarity statement that gives the scale factor. So in number 1, I've got my two triangles here. I can see I already have one pair of angles that are congruent, which is angle H and angle K. There is nothing else marked for me in the picture. However, I know that right at the center here where I have two angles that make an X, these are vertical angles, and I know that vertical angles are congruent. And so you will never have vertical angles marked for you on a picture. You're always going to have to mark them yourselves. So at this point, I have two pairs of angles that are marked as congruent. And one of these similarity theorems that proves triangles are similar is angle-angle. So yes, these are similar triangles, and I used the angle-angle similarity theorem. When I go to write my triangles, I need to make sure I write them in order. So I'm going to name the triangle on the left HMG. And I'm going to say it is similar to the triangle on the right, and I have to name in the same order. So H matches up with K, M matches up with M on the other side, and then G matches up with J. So it doesn't matter which order you write the first one in, but the second one does have to go along in the same order. Number 2, I've got two different triangles and they are overlapping triangles. So I have this triangle here, OKJ, and it is laying on top of the other triangle over here, which is ONM. So I've got this orange triangle on top of the blue triangle. So I'm going to take a look at the side lengths for each of these. Now, what I do notice is that because these are overlapping each other, they end up sharing this angle O right here. So I already have one angle that I know is congruent in both of the triangles. Angle O is congruent to angle O. So if I were to separate these two triangles, if I were to look at this orange triangle over here, the side length is 30. And I can write a proportion or a fraction to kind of make a look at the other side of the triangle. So the one that is in the same position or corresponding position as OJ on the blue triangle is O to M. It's the whole thing. Now this whole length is 30 plus 10 because it's the whole distance, which gives me 40. So my fraction for this side is 30 over 40. Equals, and then I'm going to do the same thing on the opposite side. Now, because I named the side that was the orange triangle first, I'm going to name that as well for the other triangle. So I've got 3 for the other side, and then again for the whole triangle, this whole side length OM, I have 3 plus 1, which gives me 4. So I can put these into my calculator, or I can just take a look. I know that 30 divided by 40 reduces to 3 over 4, and that is the same as 3 over 4. So I've got two sides that have the same scale factor, 3/4, and I also have an angle that they share. So I've got two sides and an angle right in between them. So these are similar triangles by the side angle side similarity theorem. So again, I'm going to name my triangles, and I'm going to name the first one as triangle OJK is similar to triangle again, and now I have to do the blue one in the same order, so OMN. And there's my similarity statement. Number 3, if I take a look at these two triangles, I see that I have all 3 sides given to me. So if they are similar, that means all 3 sides have to be proportional. So I'm going to make a proportion for all 3 sides and see if they are the same or different. If they're the same, then my triangles are similar. If they are different, then my triangles are not similar. So I just have to match up pieces that are in the same position, corresponding positions. So in this picture, 4.2 and 21 match up. So I'm doing the small one divided by the big one, essentially, the small triangle divided by the big triangle. And so whatever order you pick, you have to keep the same order for the rest. So 3 matches up with 15. And then 3.4 matches up with 17. So I'm going to take my calculator. I'm just going to divide these numbers and see if the decimals are the same or if the decimals are different. So this first one is 4.2 divided by 21 is 0.2. 3 divided by 15 is 0.2. So those are the same. And then 3.4 divided by 17 is also 0.2. So all 3 sides are exactly the same. All 3 sides are proportional. So these are similar triangles by side, side, side similarity. Okay, so I can't really name these triangles, right, because I don't have letters for you, but I know that this is the scale factor right here, 0.2, because that's what the proportion comes out to be for all of them. All right, number 4, find the length of UT. So this piece UT right here is the mid segment. So I know that if I double the mid segment of this smaller triangle here, I should get this length over here in a corresponding position, which is KM. So if I double UT, I should get KM. So I'm just gonna plug in the equation and do a little bit of algebra. So 2 times side length UT, and I'm doing the entire equation, which is 2x minus 2. Equals this last side length over here, km 3x plus 2. And so then it's just some algebra. So the first thing I'm gonna do, excuse me, is I'm going to distribute the 2. So 2 times 2x is 4x. 2 times negative 2 is negative 4. Equals 3x plus 2. Now, Ms. Damaso likes to, when I try to get all my x's to the same side, I like to move the smaller x value. So I'm going to take this 3x and move it over by subtracting it. So I've got x minus 4 equals 2. And then the last step is add 4 to both sides. So my x value equals 6. Now, the question, though, asks me to find the length of UT, which is this length right here. So I'm going to take my x value. I'm going to substitute it into the equation for UT. So UT was 2x minus 2. So instead of an x, I'm going to plug in a 6. So 2 times 6 gives me 12, and 12 minus 2 gives me 10. So UT equals 10. Just as a little side note, my scholars, you are not doing that on your quiz. This is for Ms. Herder's scholars and others as well. Okay. Number 5. Kristen lives directly east of the park. The football field is directly south of the park. The library sits on the line formed between Kristen's house and the football field at the exact point where an altitude to the right triangle, formed by her home, the park, and the football field, could be drawn. The library is 2 miles from her home. The football field is 5 miles from the library. Question number 1 asks you to find how far is the library from the park. So here's the library from the park. I want to know what is this piece right here. So I'm going to call that X. Now, this piece, because it's this center piece right here in the middle, that is the altitude. So I am trying to figure out what is the altitude for this triangle. And so if you remember the geometric mean, to find the altitude, I take the 2, I'm trying to find the geometric mean of this altitude. So I take the segment divided by the altitude is equal to the altitude divided by the second segment. So in this picture, my altitude is X. My segments are the 2 other pieces over here at the hypotenuse of the large triangle. So my segment is 5 divided by my altitude is X equals my altitude is x divided by my other segment is 2. So now I've got my proportion, and I'm just going to cross multiply. So x times x gives me x squared. 5 times 2 gives me 10. So my equation is x squared equals 10, and then to take the x by itself, I take the square root of both sides. So when I put the square root into my calculator, I know I'm gonna get a decimal. So square root, I get 3.16-ish is my altitude. So this is 3.16. Next part asks me, how far is the park, excuse me, from the football field? So now I want to figure out this piece y over here, right? So this is my y piece. Okay, so this time I am not looking at the altitude, so I'm going to have to use the hypotenuse leg theorem, which says essentially you take the segment, or excuse me, the hypotenuse over the leg is equal to the hypotenuse over the leg. And I've got a big triangle and a small triangle that I'm looking at. So if I look at my big triangle, here's the big triangle. I'm going to start by looking at the hypotenuse and leg of that blue triangle there. So the hypotenuse is across from the 90. It's this entire length. The whole length is 5 plus 2, which gives me 7. So my hypotenuse for the big triangle is 7. Divided by the leg that I'm trying to find, the other piece is y. So 7 over y is my first proportion. Now I'm going to have to do the hypotenuse leg of, I should really use a different color, but the smaller triangle that touches this y. So that would be this triangle right here. So again, here's the 90 degrees. My hypotenuse is across from the 90, which is y, divided by the leg of this pink triangle is 5. So my proportion is 7 over y equals y over 5. And now I'm going to cross multiply and solve. So y times y gives me y squared. 7 times 5 gives me 35. To get the y by itself, I square root both sides. I get y is approximately 5.92. And I really should put miles for both of these because I'm talking about miles. Okay, and we're done there. Number 6, solve for x. So I see, here's my altitude in the center. I see this is a piece on the outside, which means, again, I'm going to have to do the hypotenuse leg theorem. So hypotenuse leg equals hypotenuse leg. So I start always with my really big triangle here. Here's my big triangle in blue. So the hypotenuse of that big triangle, so here's the 90 degrees, I go across from it, this is the hypotenuse. Now, you will notice you've got a 9 and you've got an x. So the hypotenuse is if I added these two together. So it's 9 plus x. Divided by the other leg of this blue triangle is 13. So there is my first proportion. 9 plus x over 13 equals, now I need to pick the smaller triangle that is touching the x value here. Actually, I can actually pick this one over here, I lied, because this one I can see I already have 2 numbers, which is going to make my life a little bit easier. So if I take a look at this pink triangle here, I go across from the 90, the hypotenuse is 13, and then the other leg is right here, this piece, which is 9. So you really always want to pick the 2 so that the diagonals match each other, right? Because in my last problem I had y's and y's matching, and this problem I have 13 and 13 matching. So now I'm going to do a little bit of algebra. Cross multiplication. So 13 times 13 gives me 169. And then I have to do 9 times the whole equation, 9 plus x, which means I have to do a little bit of distribution. So I'm going to distribute that 9. 9 times 9 is 81. 9 times x is 9x. So I've got my x's by themselves. I'm going to move the 81 to the other side by subtracting 81 from both sides. I've got 88 equals 9x. And then the last step to get x by itself, I divide by 9, divide by 9. I get a decimal. I get x is approximately 9.7777, repeating. Or you can put 9.78, something like that. Okay, and there you go. All right, last one here. Solve for x, y, and z. So this time you got a whole bunch of different ones to do. I always suggest starting with the altitude because that one is always going to be the easiest. So here's my altitude, and let me go to the two other pieces of the segment, which are 3 and 15. So remember to find the altitude, which is the y value in our problem here. We're going to do segment over altitude, 3 over y is equal to altitude over segment, y over 15. Doesn't matter which one you did first. All that matters is that your y's, your altitudes, match up. So I'm going to do some cross multiplication. Y times y is y squared. 15 times 3 is 45. So to get the y value by itself, I will square root, and I get y is approximately 6.71. There's my y value. It's first part. Okay, number 2. Now I'm gonna solve for the, x now. So I'm gonna take my whole segment here, here's the really big one, whole triangle. And I know that I'm gonna have to do some hypotenuse leg. So my hypotenuse is 3 plus 15, which gives me 18. So my hypotenuse is 18, divided by the leg that I'm trying to find is x. I set that equal to, I wanna use that x again, so I'm gonna use this smaller triangle here. Hypotenuse of this blue triangle is x over the other leg that's given to me is 3. So again, you always want these to be matching up. So here was my big triangle. Here was my little triangle. And now I cross multiply. So x times x is x squared. 18 times 3 gives me 54. To get x by itself, I square root, and I get x is approximately 7.35. Okay, last one is, so I can actually put that in the picture if I want, 7.35. This one's 6.71. Last one I'm going to solve for is this z value over here. Again, I'm going to do hypotenuse leg. So I'm going to go again with my big pink triangle because that one's already given to me. So my hypotenuse is 18 divided by the leg I'm trying to find is the z. Hypotenuse leg. Now this time I'm going to have to use the other triangle. So I'm going to do it in orange here because, I'm trying to find a different variable, so I need to use a different part. So here's my orange triangle. Hypotenuse is z over the other leg given to me was 15. So making sure that your diagonals always match up. That's an easy way to just tell that you did the problem correctly. So z times z is z squared. 18 times 15 is 270. Last step, get z by itself, square root. I get z equals 16.43. Okay, and there you go. You had to do 3 different ones for that problem there. All right, let's flip it over and do the back side. All right, let's take a look on the back side. So for numbers 8, 9, and 10, we are solving for x. We've got some similar triangles. And we're going to make some proportions based on the picture themselves. So in number 8, we see that there are these two angles here that are marked as congruent, and I know they're congruent because they both have this arc mark on them. So because of that, I know that this angle is being bisected, right? Cut in half. So because it's being cut in half, this line right here is my bisector. So I'm cutting this triangle into two proportional pieces. So because of that, I can write a proportion based on the side lengths. So what I always do is I go find the angle that's being bisected. I go directly across from the angle. The two pieces directly across from the bisected angle are your first fraction. So my first fraction is going to be 10/8. Then I take the other two pieces that are left over, which is 3x minus 1 and 16, and that will be my second fraction. And I need to make sure that it's in the same order as before. So since I picked this triangle on the top first with the 10, I have to also pick 3x minus 1 to go on top as well. So it doesn't necessarily matter which one you do first, as long as you keep the order the same. So from here, I'm going to do some cross multiplication. So 10 times 16 gives me 160. And I set that equal to the other two sides, which is 8 times the whole 3x minus 1. So I'm going to have to do just a little bit of distribution here. So I take this 8 and I give it away to everything inside of the parentheses. So 8 times 3x gives me 24x. And then 8 times -1 gives me -8. My x's are already by themselves, so I'm going to add 8 to both sides. I get 168 equals 24x. And then to get my x all by itself, I divide both sides by 24. So when I put that in my calculator, I get 7 equals x. And the problem only asked me to solve for x, so I'm done. Number 9, calculate the value of x. So this time I notice that I have two triangles that are overlapping each other, and I also see that I have these arrows here, and those arrows mean that these two lines are parallel. So when the lines are parallel, I can write equations based on the segments that are on the same side. So I pick two pieces that are on the same side. So that would be 3 and x minus 2. They're both on this same length of BD, so that's my first fraction, 3/x minus 2. I now come to the other side over here, and these two pieces that are left over are my next fraction, and they have to go in the same order. So since I did this like top piece divided by the bottom piece, I have to do the same over here. 5 divided by x plus 6. And then it just becomes algebra, your fave. So I'm going to cross multiply. So I'm going to do 3 times parentheses x plus 6. It's a whole equation, so I put it in parentheses, equals, do the same on the other side, 5 times parentheses x minus 2. And now I'm just solving this algebra problem. So just like before, I'm going to have to do some distribution. 3 times x is 3x. 6 times 3 is 18, and it's a positive. Equals 5 times x is 5x. 5 times a -2, be careful, is -10. Now I want to get all my x's to the same side, so I always take away the smaller x. So the 3x is my smaller x, so I'm going to subtract the 3x from both sides because it was positive. Working from left to right, I have 18 equals 2x minus 10. Now I'm going to move the constant to the other side, so I'm going to add 10 to both sides. I get 28 equals 2x, and then I divide both sides by 2, the number in front of the x, and my final answer is 14 equals x, or x equals 14. Either one's fine. Okay, last one like that. Excuse me. Again, I see parallel lines, so I know that I can write my equations based on the two segments on the same side. So I'm going to look at this longer side here first, and I know that these two pieces are my first fraction. So it's x plus 8 over 35. And I'm going to set that equal to the other side. Now, on the other side, I know one of my pieces is 6, but I don't know what this piece over here is. And now when I'm writing my proportion, I'm doing the pieces to each other. However, I do know that this entire side length is 21. So if I've already used up 6 of the 21, I'm just saying, hey, what do I have to add to 6 to get to 21? Or in other words, if I subtract 21 minus 6, I should get what this piece is. And that gives me 15. So now my second fraction, I have to put it in the same order. So I did top divided by bottom. So I'm going to do top divided by bottom. 6 divided by 15. And now, again, it's just a simple algebra problem, so I'm going to cross multiply. So 6, excuse me, times 35 is 210. And I set that equal to 15 times the whole equation, x plus 8. Okay. So I'm going to do, again, some distribution. Hopefully you're noticing it's a lot of the same things over and over again. So 15 times x gives me 15x. And then 15 times 8 gives me a positive 120. So my x's are by themselves. I'm going to move the constant to the other side by subtracting 120 from both sides. I get 90 equals 15x. And then to get the x by itself, I divide both sides by 15. So 90 divided by 15 gives me that my x value is 6. And I'm done with that problem. Number 11. Draw the image after the given scale factor. So the scale factor is 1/2. The center of dilation is the origin. Remember, dilation means you're taking something and you're enlarging it or you're shrinking it by some amount. So if I'm enlarging it, it should be a number. The scale factor has to be a number that's greater than 1. So like if you double something or triple something. But if my scale factor is a fraction that's less than 1, so 1/2, that means I'm taking half of the original figure. So since I'm taking half, I'm going to be reducing my figure, making it smaller. So what I'm going to do, I'm going to write the original points of the coordinates, and then I'm just going to multiply by the scale factor. So point C is 2, 8. Point D is, I go over 6 up 2, 6, 2. And then point E is go over 2 up 2, so that's 2, 2. So remember, we always multiply by the scale factor. So I'm going to multiply by 1/2. Or the other thing you can do instead of multiplying by 1/2, that is the same thing as dividing by 2. If you multiply by 1/2, put in your calculator, you're going to get the same thing. So when I write my new coordinates, I need to make sure I put a tick mark or a prime next to them. So 2 divided by 2 gives me 1. 8 divided by 2 gives me 4. So C prime is at 1, 4. So I go over 1, up 4, and I mark it as C prime. D prime, so 6 divided by 2 gives me 3. 2 divided by 2 gives me 1. So I go over 3, up 1. That is D prime. Notice I'm putting the primes next to mine. Last one, E. 2 divided by 2 gives me 1. 2 divided by 2 gives me 1. E prime is 1, 1. E prime. Connect. You should get the exact same shape, just a reduced version of it, a little bit smaller, and it should be getting closer to your origin or the center of your dilation. So the smaller it gets, the closer it should get to the origin. The bigger it gets, the further away it's going to be from the origin. All right, last question. Number 12. Given the coordinates for the vertices of triangle ABC and the coordinates for A prime, determine the scale factor and determine B prime and C prime. So what I have here is my original, these are my pre-image. The new one here with the tick marks are my image. So what I need to do is determine how did I get from A to A prime. So how did I get from 36 to 12? And how did I get from negative 12 to negative 4? So what I have to say to myself is, hey, look, first of all, if I'm changing from 36 to 12, I'm definitely getting smaller. I'm reducing. So my scale factor should be a fraction. To find your scale factor, all you have to do is take the image and divide by the pre-image. Or in other words, you take your prime and divide by your one that does not have a prime. So you can either choose your x's or your y's, it does not matter. I'm going to choose my x's because I don't want to deal with negatives. So my a prime was 12, divided by my a was 36. I can reduce this because I can divide both of these by 12. So if I reduce 12 divided by 12 gives me 1, and 36 divided by 12 gives me 3. So my scale factor is 1/3. My picture got smaller, which it did. So my scale factor, my k, is 1/3. Remember, we use k as our scale factor. So now, knowing that my scale factor is 1/3, I'm going to take my points, my b and my c, and I'm going to multiply by the scale factor. So my b is -30, 15. So I'm going to take that and I'm going to, just like I did up here, I'm going to multiply by my scale factor of 1/3. Multiplying times 1/3 is the same as dividing by my denominator, which is 3. So -30 divided by 3 gives me my b prime as -10, and then 15 divided by 3 gives me 5. So my b prime is -10, 5. My c point was 24, 21. Again, I'm going to multiply by 1/3, or I can divide by 3, get the same answer. So my c prime is 24 divided by 3 gives me 8. 21 divided by 3 gives me 7. So multiplying times 1/3 is the same as dividing by 3. Okay, so now we are finished with our study guide. Hopefully that helped you out. Remember, your test is going to be over similar triangles, being able to write the proportions, geometric mean, and dilations, reducing or enlarging my picture. Okay, hopefully that helped you out. Good luck on your test.